In the next few minutes, you will learn about CA's solution for infrastructure provisioning of the FlexPod data center. This is a converged infrastructure offering from both NetApp and Cisco. We are really excited to show you how our solution for FlexPod, which is called CA Automation Suite for Data Centers, is able to help our mutual customers meet their business needs. The following demo is based on an actual proof of concept that we completed for a large enterprise customer who is deploying FlexPod in their data center environment. These three use cases given to us by the customer were meant to demonstrate and verify our solution's functionality. The first use case was to provision a new VMware ESXi 4.1 host on a Cisco B200 blade. The second use case was to provision and attach a new NFS data store to this ESXi host. The last use case was to provision the virtual distributed networking components on this ESXi host. We will demonstrate to you how we accomplish this in just a second. But first, let's have a look at the underlying hardware components that make up this customer's FlexPod environment. The NetApp FlexPod hardware components used with these test cases include a NetApp FAS 3040 cluster running ONTAP version 7.3.5 with 4 shelves with 300G fiber channel per controller, a Cisco Nexus 5010 switch with 2 10GB Ethernet links, a Cisco UCS 6120, and a Cisco UCS equipped with 4 B200 blades and 8-core 48G per blade. In addition to the software components being configured, the FlexPod used in these test cases include CA Server Automation, CA Scalability Server, VMware's Data Fabric Manager and vCenter Server, and Cisco UCS Manager. Using CA Solution, the user can provision a new physical, virtual, or public cloud machine all from one location. We also have a unique imaging feature which allows us to capture a live system and redeploy this to new infrastructure. This is a great way for customers to move legacy hardware to a FlexPod or for customers who want to move VMs into and back out from the public cloud. The user can also provision applications and patches to those machines. The FlexPod environment offers a complete server lifecycle solution. First, we need to choose our UCS options. Typically, customers will have more than one UCS manager, so it's important that they can centrally manage these. The service profile allows the user to define the characteristics and interfaces of the new server. We can create a new service profile or synchronize service profiles between multiple UCS managers. Next, we need to select which chassis and blade to use. It automatically shows the hardware information for that blade. Then we need to provide some basic information about the ESXi server, like hostname and image selection. Selecting the scalability server allows us to provision as close to the managed resource as possible, instead of pumping gigabytes over the WAN. Finally, we give it some additional options for the ESXi, and we're good to go. Our blade gets the right service profile assigned and is automatically powered on. Then our boot image is deployed. Note that this is a universal method, which we also use for provisioning Windows and Linux servers. Then, our ESXi OS image gets deployed. This is the end result of our ESXi host provisioning use case, a fully functional VMware ESXi server, ready to be consumed in vCenter. Now, let's add some storage to it. In our second use case, you can see our ESXi host only as a local disk. Using the same interface as before, we can now provision and attach storage to our host. We pick our provisioning method, which can be a storage service, or if you want a bit more control, can be a storage policy. We then give it some information about our host, our data store name, and tell it which DFM we want to use. Before we select our storage service, we can look at the details of that service. We tell it which protocol to use, in this case NFS, and hit Finish. At this point, our storage is not only provisioned, but it is also attached to our ESXi host. Typically, these are two separate operations performed by two different teams who have to wait on each other. Now, using CA Solution, we can complete this in one operation, providing greater agility and lowering the operational costs. As you can see, the end result is a new NFS data store attached to our ESXi host. As you can see, our vCenter has a couple of data centers already defined. We are going to add a new data center, add our ESXi host to the data center, and take it out of maintenance mode. You are looking at our CA Process Automation product, which allows us to glue these different operations together. This is what we would use for a one-click infrastructure provisioning functionality. It basically hooks back into the functions you've seen previously. CA Process Automation has connectors for NetApp, Cisco UCS, VMware, and many other products. Okay, so now we have our new data center and our new ESXi host attached to it. Now that we have our ESXi host in vCenter, we want to automatically add some networking components to it. In our use case, we wanted to set up a new VMware virtual distributed switch. We also created a use case where the user could actually select the VMware VDS and select how many VD port groups and associated VLANs he wanted to create. This brings us to the end of our session. I hope you've seen in this short demo how CA's automation suite for data centers can speed the migration to and simplify the management of FlexPod environments.